Okay. Now it's going. All right. Verify it. Hello. Hi. Okay, I can see you, Vlad. Can somebody please confirm that you are able to hear me? Just type in comments here.
Yeah.
No.
It started just now.
Well, Dave Kant just mentioned, okay, maybe it's not.
No, there's a bit of a lag.
Okay, let's see if somebody can hear us now. Yes, okay. So it seems like there's some audio quality issue. Yes, audio quality issue on my end, but Vlad, you should be okay with that. So what I'm gonna do is, hey guys, we'll start today. Today I have a special guest with me, Vlad, who is, yes, Dave Khan, thank you. Thank you for mentioning that. So Vlad is our lead instructor or instructor for our data science for marketers program, and also runs Python classes on Optizent Academy. And he and I have done several sessions in past on how marketers can start to use data science. Last week, I interviewed one of the lead recruiters. He works for a global recruiting company, and I'm connected to a lot of recruiters from that company. And I constantly see these job postings which mention Python, SQL, all the data science stuff, along with Google Analytics, Adobe Analytics, etc. And when I interviewed him last week, you can check out that video. It's available on the channel where he was talking about digital data science or sort of like that requirements that are coming up. And Vlad and I have been talking about this for quite some time, and that's how we started this whole Python on this channel and teaching Python, because I feel the same looking at and talking to people who are hiring, that this is one of the most critical thing or skills that employers are asking. So we have started a program, which is a 10-week hands-on program that'll teach you nuts and bolts using digital data. So you'll be using Google Analytics, email, marketing, display advertising, Google Ads, etc. data, and use data sciences, which is you learn Python and how to use Python to find insights in that data. And today on that same theme, Vlad will discuss how you can predict ad clicks. Ad clicks is one element of your advertising. If people are not clicking, they're not coming to your site or not interacting with your landing page, right? So first step is to get them to click. And once they click, then there are other elements come into play. The data also gets richer once they click on that. But today we'll focus on how you can predict which ads are going to get clicks. And Vlad, correct me if I'm wrong here, jump in and say, no, this is not what I'm going to be doing today.
So
but that's my
correct, yeah.
Yeah, so that's my expectation here is you will be doing, showing us how to do that. And the end goal really is for you guys to understand that it's doable, how you do it. He's going to do it. Only we have an hour or so to get this done. So we can't show you everything, but enough for those who want to or who are self-learners can go learn on their own. And if you want to get help, then we definitely have this program. That's the only program that I can think of in the world that talks about just marketing analytics data using Python. And you'll learn nuts and bolts of that, and you will be ready for the next job that's coming up. I actually posted another job from, I think it was from Yelp as well on my Facebook group, which is people are asking for these skills. So with that, I will hand it over to Vlad and let him talk about today's session and what he's going to show us. If you have any questions, feel free to type those questions here in the conversation. I will be reading those questions to him. I will be stopping him if I feel, hey, something is not clear.
Yeah,
but
please.
I expect you guys to mention that to me in comments. There is a bit of delay. So by the time I speak or he's speaking and you guys hear, there will be a bit delay. So keep that in mind when you type a question. He might already be talking about some other topic, but I'll bring him back at the right time. So, Balad, go ahead
Yeah.
and take it over.
Thanks, Anil. First of all, thank you for featuring me on your live YouTube channel. It's a pleasure to be here. And also thanks for the opportunity to speak about predictive modeling in digital marketing. It's a really a bunch of interesting topics. So we can use predictive modeling to predict, various parameters, various types of KPIs, for example, that we are interested in. So today I thought I would bring one study that is very not only interesting but also kind of multifaceted, right? So we will talk about predicting ad clicks, okay? And what are ad clicks? What is a click-through rate? That is a parameter that describes the efficiency of your digital marketing platform, right? So predicting it is going to be really helpful for the platform as well as for the advertisers, right? So to make sure that money is spent efficiently, right? And basically that we are generating revenue, generating profits. So also additionally, there are some other things that could be also addressed with predicting ad clicks. One notable thing is, there is such a concept as click fraud that unfortunately happens with online advertising platforms, and efficiently predicting ad clicks may actually help us understand when click fraud is happening, right? For example, we can try to infer about all kinds of anomalies that are happening with clicks. This is not a trivial thing. I just dug out a PhD thesis on click fraud detection, right? So it doesn't seem to be a very intuitive or trivial problem to solve, even if we know all the predictive modeling tools.
Yeah.
And the reason is that, human behavior is an anomaly, right?
Yeah.
Naturally. So detecting anomalies on top of it would be extremely challenging, but still, it is happening now.
Yeah. And actually, on the click fraud side, a lot of ad publishers such as Google, Facebook are doing a lot on their end to detect that and not charge for those clicks. However, in my experience, when I've worked with other publishers, so you're not dealing with just Facebook and Google, right? If you are in a large organization, your ad might be running at several places, CNN, maybe MSN, Yahoo, whatever, pick your networks. And there could be ad networks. In one case, this was several years ago, we did notice some anomaly in the behavior for clicks coming from a particular publisher. It was a huge spike, right? On the surface, when you just look at aggregate numbers, it looks like, hey, that ad is working because you're getting lots of clicks if you're just measuring the clicks, which is not the right way to measure success anyway, but that's step one, right? When you look at that and you said this ad is working, but once you start to dig into the data, that's when you start to find out what's going on, right? It's either the ad click fraud is going on because they are inflating the clicks by making bots click on it, or it's might be just another bot just trying to find something and click on it. And this is what I mentioned in all my classes: is spiders and bots are huge on the web. Many sites, smaller sites have about 90% of their traffic is spiders and bots. Bigger traffics have 50, 30, or 30 is the minimum I think you'll get to. So that creates a problem. And this is where Python can, or data scientists can really help us find out, is it human? Is it not, right?
That is true, because when you dig deeper into the patterns of whatever, series of events are happening on the web, you will start actually being able to detect the type of behavior behind these patterns. And I'm sure that, you can tell whether, this is a bot or a human, or is this a human but clicking for higher just so that they can inflate the click-through rate. and overcharge the advertiser for that, right? So we don't want that. We want our business to be fair. We don't want that to happen. That being said, also the mainstream motivation for CTR, click-through rate prediction, is still understanding our strategy in advertising, right? So the problem itself is kind of multi-layered, right? So you want to understand the strategy, you want to have some kind of a very aggregated, high-level understanding. So that's one thing. Another thing is more real-time understanding, especially if we are operating on the real-time bidding basis, right? So we want to be able to understand whether immediately within milliseconds kind of generate prediction on whether this kind of impression will generate revenue or not, right? And make a decision. So I like this problem because in teaching data science, the click-through rate problem allows me to cover a lot of different angles and approaches and methods in machine learning and data science, because you can solve a bunch of problems with click-through rate data sets, and then you can, if you want, you can actually combine the solutions and make a unified solution that will be very powerful, because it will be predicting pretty much everything around
everything. Like, and that's what excites me is
that's one thing. But in many cases, we are interested in something more specific rather than put our efforts into developing a theory of ad clicks, which might not be a bad thing, but it could be very time and effort consuming. But sometimes we just want to solve a specific problem with this. Okay, so I'm glad also you mentioned Google and Facebook, because those are, well, let's get the word leaders in digital marketing. Okay, and they are actually approaching ad click prediction from very different angles, which are based on the way their businesses operate, right? Because Google specializes mostly in what they call sponsored search, right? So when someone types a query into the search engine, Google's predictive machine starts immediately generating a list of candidates to display to the user. So their challenge, I like their approaches, and by the way, both Google and Facebook, they actually publish their findings in open. So I was able to dig out a couple of papers that describes both Google's and Facebook's approach to predicting clicks. So the paper that was published by Google that I was looking at was called Ad Click Prediction, a View from the Trenches, right? So the actual settings, right, for predicting ad clicks for Google is a very kind of, I should not call it hostile, but it's a very difficult situation where you need to quickly predict just simply from a single phrase, right, from a single bit of text. You will have to predict what this particular user might be looking for. Okay. Now, Google is, of course, famous for as a search engine, so they have a lot of predictive tools that are based on natural language processing, right? Some of those tools are available for basically they are available as open source tools. Such as, for example, there's one called BERT, right? That was developed initially as a way to extract knowledge from bits of text, right, from natural language. And of course, Google uses queries as the primary tool to predict the potential interest of the user, right? Why? Because not most, but I can't really tell what percentage, but a big chunk of searches is anonymous. So you might be using the anonymous mode in, let's say, Google Chrome or other browsers, and still get adequate, relevant, sponsored pages that would be based only on your search. So Google will try to detect interest. Of course, if you are coming in as a logged in user, then they have more features to learn from, because they have your browser history, and of course Google logs every bit of everything that is happening online, like your location and anything else. Then the problem becomes not easier to solve, but there is more information that will support this predictive model. But in the most severe kind of case, it's just anonymous user. typing words. So Google's approach is really based on predominantly on natural language processing and analyzing not only the text itself, but also I believe the behavior, typing behavior, the way you are typing. So they have these, very complex deep learning models that now allow us to, not us, but allows Google to actually generate right sponsored results. Right, so that's Google and Facebook's approach is very different, right? Facebook is a social network, right? It's not a search engine. So for them, they deal mostly with logged in users, right? Users with well-known profiles. So for Facebook, I would say the problem is easier to solve, right? Well, because you know a lot about the user already. So for Facebook, targeted advertisement will be really based on a combination of user profiles, so the metadata about the user, plus all the activities that the user performs online. So for them, I guess in another paper that they found on Facebook approach to ad clicks prediction, it's going to be based more on more traditional machine learning models, such as classifiers, such as logistic regression, or tree-based classifier, or I guess ideally a combination of both. Okay, that being said, I guess they are also developing really advanced methods in predicting ad clicks. So both Google and Facebook are really worthwhile, keeping an eye on in terms of the newest and the latest in predicting ad clicks. Okay, so so that being said, when we start talking about this problem, or when I teach machine learning and I offer this problem in class, we will actually start with the basics, right? With the basics of predictive modeling, and see how far we can get with it. So yeah, so there is actually there is an interesting data set. It was published by Kaggle. There was a Kaggle competition. Let me show it to everyone on the screen.
So I have a question, Vlad, here.
Absolutely.
Regardless of what data you are collecting or source, what are the Python tools and processes for handling the data? This is Karen is asking that question.
Yeah. Okay. Yeah, that's a good question. So let me still share my screen. Will be easier probably to talk to it. But Python tools. Well, sorry, one at a time. So actually, I was going to pull up the Jupyter notebook which always helps me to talk through, Python examples. But let's look at the data first, or let's look at, let's look at the Kaggle competition page. It was done a number of years ago, so the prize has been awarded already. They paid $15,000 to the winner, which is kind of a reasonable amount of money. Okay. So this Kaggle data set is now available for academic use, which is great. So we can basically teach based on it, right? We can download it and basically generate predictive models based on this data set. So now, as far as Python tools, so let me just maybe digress generally into Python generally as a data analytics tool. So Python is, first of all, Python is a general programming language. Historically, it wasn't really designed specifically for data analytics, but over the past, say 10 to 15 years, Python, because of it being object-oriented, right, and very suitable for data analytics. Plus, there are other advantages of Python. It is also very much based on natural language, so it is, I shouldn't say easy to learn, but it is more intuitive. So the learning curve when you're learning Python from scratch is much friendlier than if you're learning, let's say, Java or especially C++. So Python is really more comfortable for new developers or for someone who is just learning to program. But anyway, so over the past 10 to 15 or maybe even 20 years, Python has become has gradually become the tool of choice for data analytics because Python is object-oriented, right? So in Python, you can describe a complex data object, such as, for example, your entire spreadsheet, as just one variable, right? And perform manipulation programmatically on this object, right? So you can program it so that it repeatedly performs transformations of the data in that data object. So because of this property of Python, it has developed as a core tool for data analytics. Okay, so when we just start introducing Python for data analysts, we first focus on its ability to efficiently manipulate data. So we start with tabular data that looks something like this that I have on the screen. Okay, and we actually can learn about programmatic manipulation of this type of data. Okay, so think about whatever you can achieve with Microsoft Excel and with SQL together, but with a lot more actually features, a lot more capabilities than the manipulations that you can do either on your desktop using point and click tool such as Excel, or using SQL, which is designed specifically for relational types of data, right?
Mm-hmm.
But in Python pandas, you can manipulate any kinds of tabular data very efficiently and fast. Pandas is actually very fast. So we start talking about first structural data manipulation. And then we talk about data visualization. So you can efficiently visualize data with keeping in mind that the goal of the visualization is your own understanding of the data you're working with, right? Plus, also you can create visualizations for reports, thus enabling your colleagues and let's say executives or anyone in your team who is not necessarily a quantitative person, easily understand what the insights are and what you are doing, right? So after introducing these tools, we move on to talking about predictive modeling. So predictive modeling is the core part of the training that we are offering, and it's basically also the core set of tools for a data scientist, right? Because modern data science is based on machine learning to a much greater extent than it is based on traditional statistics. The reason for that is we work with really, really large data sets that are rapidly changing. So traditional statistics doesn't give us all the predictive power that comes from machine learning models. Okay. So at the high level, trying to answer the question, the tools are first dealing with structured data, visualization, and prediction. So 3 core themes in developing these tools in Python. Okay. So yeah,
Okay.
please keep
Karen,
asking questions.
Does that sound right, Karen? I just want to make sure.
Yeah.
She gets the answer. All right.
If there is a bit of a lag, but then we will probably
okay. We'll come back later if there is a response.
But feel free to interrupt me because I really enjoy answering questions. Now let's go back and look at the Kaggle data set that they offered to the contestants to predict the so-called click-through rate. Okay.
Mm-hmm.
So
can you give us a bit of background on this data? What is this? What are we looking at?
So data comes from the company called Avazu, right? Mm-hmm. That's the company that was Kaggle's client, and they kind of offered the data set for public competition in a hope that someone, a machine learning expert, will come up with a very high precision model mm-hmm. that allows them to predict clicks. Okay.
So this is basically telling us for each ID or each kind of banner ad, right?
Right.
Or whatever kind of ad is, how many clicks we got at what hour. I'm not sure what C1 is, but maybe it's a creative element.
Well, yeah, let me explain the data a little bit, because in this case, when the data is highly proprietary, what the client of Kaggle does, they anonymize a lot of fields, which is a bit of a problem.
Challenge, yeah.
Yeah, because this becomes a pure machine learning model without any expert input in it.
Yeah.
Which is, I guess, when you're practicing machine learning, this is fine, right? When you're actually applying this methodology to your work, then
you need to understand what each element means,
exactly,
which is affecting. Yeah.
So it's one thing is to precisely predict what's going to happen, but another thing is to use predictive models to understand what is happening, right?
Correct.
To me, the understanding part, because well, I'm a data scientist, I'm kind of biased towards that, but to me, the understanding part is even more important because it gives you transferability of your knowledge, right? So once you understand one problem,
I mean, you have to be able to apply it to business, right? You're not just running for the sake of creating these models.
Well, I mean, you still, but by precisely predicting clicks, you are still generating a lot of revenue. But the other part again is knowledge transferability that you are trying to achieve with this.
Exactly.
But anyway, we have what we have. So the actual granularity of this data, the data is pretty granular. So it is actually, it gives you a view per device and per IP address, right?
Yeah.
And as far as temporal granularity, everything is based on the hour. So they give us hour per hour click data over a bunch of different devices, apps, and site domains and site categories, as you can see from here, from the description of the features of this data set. They give us a pretty granular view, click-by-click view. So we can learn a lot from the data. What we can't learn is whatever is hidden under the anonymized variables. So C1 and C14 to C21 are variables that,
they don't want to reveal them. Yeah.
Well, they won't reveal them because they are part of the proprietary knowledge. They will still help us to understand the differentiation, some kind of predictive power of the model, but they won't really give us a lot of knowledge about what is hiding behind these variables. But again, when we are applying what we learn from predicting on this data set to our own work, where we have access to pretty much everything that we need to know, then we'll be able also to wear our data scientist hat rather than machine learning engineer hat. And not only do we predict the clicks, but we also know what everything is about and how your system behaves. So
I want to add something here for the audience here, because a lot of audience come from the background where they're using tool like Google Analytics and Google Ads are running those things or their ads, right? So if whether it's Google Ads, Facebook ads, third party, whether it's your own ads that you're buying space on somebody else's site, you have those campaign IDs, right? So that's your sort of your variables or data elements that points that you're putting in. And then when a user comes and clicks and lands on Google, your site, you have, say, Google Analytics, and let's assume you have Google Analytics 4. Google Analytics 4 data is now going directly, or you can actually integrate with BigQuery. You will be able to get a lot of this information within Google Analytics data as well. Which ad was clicked, and how many clicks happened on that ad, what the all these device model, device type, etc. information, if your publisher is not giving you that information. So there are ways to build this data set and use something very similar to this based on what Vlad is going to show us.
Yeah, thanks, Anil. So a few more words actually about anonymization of the data. You can also see that not only do they anonymize the names of the variables here in many cases, but also when they talk about such variables that they identify as site ID, site domain, and category, same about app, and also device ID and device IP address. They don't give you the actual values here. They give you hashes, right? So what you can learn from this is your overall approach to prediction, rather than actually predicting something useful from this specific data set. So this is why I actually, in a way, like to use anonymized data when I talk to subject matter experts, because subject matter experts would look at the data and immediately start making conclusions that are not necessarily driven by purely the predictive approach, right? So I think it might actually make sense to look at anonymized data once in a while and try to kind of dissociate ourselves from our expert knowledge and just see what variables are doing and how they behave. right? So that could be a good thing to work on this data set. So now let me see what else I wanted to say. So also, you know, what we are going to be predicting from this data set is the value of the variable called click. So click can be either 0 or 1. Okay, it's a binary categorical variable, right? And what we want to do is either to predict each individual impression, whether it will generate a click or not. Okay, so this type of prediction is called classification, right? Because we are predicting two different classes, either yes or no, okay? Or we can predict the probability of a click, right? So there are two different approaches in data science. One is to deterministically predict the behavior of your system, whether a click is happening or not, or you can approach it probabilistically and try to predict the probability of a click, where the probability is going to be anywhere between 0 and 1. And of course, you want to apply your knowledge later on and try to, because when you're predicting something, right, you are mapping your predictions to all these variables that you have in your data set. So once you have a model that is working, then you can actually tell how you choose your variables such that you can maximize the probability of the click. You know what I mean? So there is still a lot of transferable knowledge in this work. Well, let alone the fact that you will be now, well, predicting on whether or not you'll be generating revenue from this model.
Correct.
So now what can we do with the data, right? So as I mentioned before, first of all, we can look at the data very strategically and try to understand click-through rate as a function of the type of application or the type of website where the ad is appearing, right? So it's going to be a very low granularity, high level type of a prediction, where we can basically strategically define the scope, you know, on where we actually want to advertise to maximize clicks. So in this case, we are actually going to ignore the fact that we actually have a per device data, right? So we can actually differentiate between different device, like physical different devices, right? But we are going to look, instead, we are going to look at the aggregated picture, okay? So this is a very high level strategic data. So the challenge here is to find how to best aggregate all the data together. Also, the data is temporal, right? So we can see a time series of clicks, right? Depending on the time of the day and the day of the week. So when we aggregate, we can actually collapse the temporal part together and look at the average response from the advertisement sites, right? So this is a very high level approach. And next level is to look at the time series, to look at the temporal data and see how, I'm showing this on my screen now, to see how the number of clicks evolves with time. Okay, so right here I'm showing the actual number of total impressions per each hour, where you can see that the number of impressions, of course, has a very well-defined day-by-day seasonality. Seasonality means a response depending on either time of the day or day of the week and so on. Okay, so this data was collected over about 10 days, okay, starting on a Tuesday. So you see that Wednesday of the first week, Thursday, Friday, Saturday, Sunday, Monday, Tuesday. So there are peaks of overall internet requests that lead to publishing the impression on your site. Okay. And again, this is all averaged across all possible locations, devices, IP addresses, right? But you can actually dig deeper and you can actually get the same picture for a specific device. But let's look at the click-through ratio. So this data, by the way, was processed and artificially what Avazu did when they published this data on Kaggle, they artificially inflated the click-through ratio, because you can see something that is very unrealistic, like 0.2, right, almost 0.3. So the realistic values for click-through ratio is more like 1 or 2%, right? 1 or 2% ads in average gets clicked on. but they had to balance the data set and they had to artificially add more positive cases to enable better machine learning, right?
Yeah, I
So,
think maybe they are also not using the total impressions. They're using no clicks on the denominator.
okay, yeah,
So not clicks versus total impressions. That'll be your click-through rate. So what they're taking is clicks out. So that's why it looks a bit higher.
yeah, okay, yeah, that's a possibility too.
Yeah. I mean, I'm looking at the Y label,
Mhm.
right? PLT dot Y label click / no click, right? That's what you're plotting on Y axis. Yeah.
Yeah, well, that's definitely a possibility. So
Yeah.
now, by applying a methodology that pertains to time series analysis, such as methods based on REMA, for example, right, autoregression and moving averages, what we can do is you can forecast this behavior
Mm-hmm.
into the next few hours, next few
Yeah.
days,
Mm-hmm.
right?
Mm-hmm.
Which could be useful. So, for example, if you look at
Correct. Yeah.
the moving average of this trend line, you see some kind of a dip that occurred on a certain couple days,
Hours. Yeah.
right? It's
Yeah.
actually a couple days because the
Oh,
total is
okay. Yeah.
150
Number of
hours.
hours from the, yeah.
So
Got it.
the whole scale is 10 days. So some kind of a dip happened for whatever reason, right?
Mm-hmm.
And this could be when you, like, if you have access to more data, then this could be part of some kind of a seasonal behavior, which will be reproducing itself later on as well, right?
Got it.
So of
Yeah.
course, the the larger time period you have covered with your training data set, then the better would be your prediction, right? But forecasting, basically forecasting clicks would be another interesting output that you can learn from this data set. Okay.
Yep.
And
Yeah, I want to call this out. Again, what Vlad is showing is based on whether the ad is going to get clicked or not, right? So we're predicting clicks, but similar stuff you can do with the conversions, similar approach, or whether even like when you have something, a PDF on your website, if you have that data at that level, whether that PDF will be downloaded or not, like what's the probability of that getting downloaded is what you're looking at based on the data elements that you have. So think about, there are so many possible scenarios with this thing, which definitely is covered, like a lot of these scenarios and assignments are covered in the complete course. But even
yeah,
if you just watch this video, you will get a great idea of how do I do this, because he's showing you the exact code that's required. Basics of Python are required, which actually is, we also run another 5-day challenge where you get the basics of Python. So that is starting on January 4th, I think, as well. And in just 5 days, you will start to learn all these different things about Python, like how do I write this syntax and opening your Jupyter notebook, etc. Right?
yeah, it's actually, yeah, it's a very good thing you mentioned it, Anil. And I also wanted to illustrate, just based on what you said about the basics of Python, you can see how if, let's say, if anyone in the audience are true beginners as far as Python goes, you can see even visually how few lines of code you will need in each of these code cells in order to generate something meaningful. So
Yeah, and
Python
you don't have to
is,
be like heavy code or anything, just basic understanding. And with going through that 5-day challenge, which is like 30 minutes or 20 minutes a day, in 5 days, you'll start to write Python more than anybody maybe in your organization knows,
Oh yeah, absolutely. So we are not really trying to actually deliver Python teaching as they would do for software developers, or someone who develops software backend for system operation. We are really interested in Python as a data analytics tool, and as a data analytics tool, it is reasonably high level, right? Where you can see that you can do a lot in basically one line of code. Okay. So the point is not to write a lot of code, because the focus here is on doing data analysis, right? Code is your support, right? It's your tool, but the point is not to write a lot of code. And in other languages, such as like C++, they don't really rely on a lot of libraries. So every time they want to code something, they actually have to write code in very low level, line by line, lots of lines of code. And again, in the data analytics libraries in Python, things are expressed at a high level, right? So for example, if you write one line of code, thousands of lines of code run behind the scene and under the hood, which you don't have to worry about, right? Because they are all combined into this high level library of where everything can be basically expressed and achieved in as few lines of code as possible. Okay, so again, don't think about Python as coding. Think about it as your data analytics tool, as much as other data analytics tools that you are familiar with. Right. So yeah, and then we can go later on. We can actually dig deeper and go at and explore device by device the behaviors that pertain to clicking or not clicking on a specific type of ad. Now we can identify devices here by device ID. So device ID could be either your mobile device or a browser, right? And the device ID is typically persistent. What does it mean? It means that you can actually log and observe certain device behavior over a period of time. For a browser, basically, as long as the user does not clean browser history or removes all the cookies, you can actually follow this browser, its behavior over days and weeks and months, whatever period of time it retains its device ID. So as a result, you can look at a specific device, right, a phone or a browser or whatever the device is, and see how this specific device responds to ad impressions. Okay, again, so on this plot, I have 3 different devices, which means physically those are the same devices, right, or browsers, and how they actually respond to how many impressions those devices receive, so that they can either click or not click on the impressions. And similarly, I can just single out one mobile phone or one web browser and see how many sorry, it has to be an O, no, new clicks, but no clicks. So how many impressions this device receives and how many clicks are actually made on the impressions. So this is on the actual physical device level. Could be useful in many cases, right? This gives you access to much finer granularity of your analysis. Now, again, in this toy data set, I call it a toy data set because it's been sort of transformed into a case where you don't really have too much access to subject matter information, but you can still practice your approach to mining data from individual devices. Okay, and here you can actually start digging even deeper. So when I say individual device, it's not the same as to say the individual human behind this device, right? So what happens typically is that human users, they own many devices, right? And some of these devices requires the user to be logged in, so you can identify the user, not by the real name, but you can actually relate to user behavior, browsing behavior, and so on, and other types of online behavior. But if you don't have access to this information, there is another method in online advertising analytics that is called device pair matching algorithm. What does it do? It actually looks at the patterns of behaviors of different devices and can actually, with certain probability, can assign this group of devices to the same human user, right? Yeah. So how is it helpful? It kind of gives online advertisers access, cross-device access, right? So if I own a laptop and a cell phone, then I do something on the laptop that triggers an impression to be sent to my laptop, but then the same impression will be sent to my mobile phone, okay? Which essentially builds additional clicks, for that same user.
Yeah, I mean, the similar stuff is Google Analytics 4 is now using machine learning to identify cross-device behavior. If it's an anonymous user, they come to your website, desktop, they do certain things. then they pick up their phone and do certain things. Now, even without having a cookie across those things or a login information,
Mhm.
using machine learning, they can figure out like, hey, it's the same user. There is definitely a probability of it being the same user or different user, but that's what they say, calculate and then say, yeah, I'm very confident this is the same user,
Yeah.
and they assign to that same user ID. So
Yeah. So
that's how.
this. Yeah. Thanks, Anil. So there was actually another Kaggle competition that was initiated by a company called Drawbridge. So Drawbridge actually specializes in this approach and in identifying what they call device graphs, right? The device graph can, with certain probability, map all the devices together and identify the probability at which the devices belong to the same human user, right? So this is one of the approaches to human identity resolution.
Yeah.
As
No
opposite to
cookie or no
device.
cookie, right? One of the things
Right?
is
Yeah.
we don't have cookies. We're not going to be living without cookies, or, cookies are going to be blocked. Sure. But
Yeah.
these companies have figured out solutions to
Oh yeah,
those. And
absolutely. So it is based purely on the behavior. So the
yeah.
winner of that competition came up with a brilliant idea. They were tracing a number of IP addresses per device, right? So device shows up at different IP addresses, and also number of devices that show up at the same IP address. So this way they can separate households from other places such as internet cafe,
Worker. Yeah.
or just Starbucks, where they have Wi-Fi or workplace. And then they're basically, watching the behavior of these groups, small groups of devices that show up at the same IP address, and then same group of devices somehow shows up at a different IP address because the user takes their laptop and phone to a different
Mhm.
place. Every time we connect to Wi-Fi, let's not fool ourselves, we are logged. So yeah, so that competition also was like $10,000 worth, and that was a brilliant approach. Very good algorithm. So here's this really multifaceted data set which we can use to practice different approaches to different methods in machine learning, including time series and classification algorithms, and also even more advanced algorithms like building graphs, device to device user graph, right? So really good data set, and I'm glad that it is available for academic use. So now we can publish papers based on it and of course use it in the classroom. So that was the Avazu data set on clicks. Now there is another type of data that is logged in digital marketing, which is called click streams. So Anil, when you mentioned conversions, we can actually go back to this type of data that is known click streams. And what click streams does, it kind of learns from the series of events that happens online.
Mhm.
For example, clicks from page to page and so on. So this is also this will basically be relying on a bit different approaches for as far as learning from this data. So we can actually go to probabilistic graph learning. So, for example, Markov process is one of those methods that could be applied to click streams. Now, if you want to learn about ad clicks and also enhance your learning if you have access to click streams data that is relevant, then
Yeah. So I'm going to mention that here. Those who haven't yet looked into Google Analytics 4, this is the time to look into Google Analytics 4. Prior to Google Analytics 4, it was very hard to get this level of data from Google Analytics, unless you went to the log files, which is web server logs. You didn't get that kind of information. But now with Google Analytics 4, as I mentioned earlier, Google Analytics 4 allows you to send data directly into BigQuery, which means every single user and every single interaction by that user is now available to you in the database or the data warehouse, BigQuery. You can create something like this very easily from that data. And once you create that, on top of that, you can run your algorithms to find out precisely which ad is going to click, which page is driving any interaction, which event, which video play, etc. Anything that user is doing, one, what's the likelihood of that happening? And also, how is that going to impact the outcome that you want? And a lot of that is going to be covered in detail because there are so many things. But think about the possibility from this session, like, hey, I can do these things. And if you are brave enough to do and try it, if you are already familiar with Python, that gives you ideas. And you can go ahead and try these things.
Yeah, that's good. So back to the training program that you, Anil, mentioned. So by the end of the training program, predicting based on these types of data sets will be something that the trainees will be able to do really easily, because all the skills that are required to analyzing these types of data. And when I say these types of data, it's not just your usual static relational database, right? So this kind of data is very multifaceted. It includes a lot of relationships between, among all the features of the data set. And generally speaking, predicting from this type of data is not necessarily trivial, even if you know all the predictive models, right? So here you basically wear both hats, right? Your data scientist hat, where you rely on data and your subject matter knowledge of the domain, and your machine learning engineer's hat, where you actually are trying to develop a high precision predictive model, right? Depending on what you're trying to achieve, of course. Okay, so as far as Python tools, I'm just showing you a copy of a very typically looking what your Jupyter notebook. This is a tool that you use to.
And are you going to provide a link to, or you can send it and I'll put it on Opticent Academy, the link to the data source so that they can look at this and then try it out on their own, right?
Yeah, I can do that. I can actually share some of this code as well. Data is sitting on Kaggle website, so the only thing you will need is you will need Kaggle account, which is free. And the data set is pretty big. It's a few gigabytes. So by the way, the training data set has about 40 million instances in it, right? So
okay. Yeah, send me the link and we can post it in the YouTube live as well as on the site so people can go and download or click there and go to Kaggle.
Absolutely, yeah, that's great.
Cool.
So there's not much. I mean, with the example I showed, you can do a few of exploratory kind of steps, but kind of gives you the feel of how Python responds to right to those tiny small code cells. So yeah, I think it's a good idea.
Cool.
Nice. Yeah, so this is pretty much what I wanted to share today. So we'll be
any questions from audience? Audience have been quiet today, except one question here. Go ahead and ask your questions, anything that you want to know, look at again. I'm going to give a few seconds because there is a delay. Cool. Meanwhile, can you drop that URL to Kaggle in the chat here for me?
Yeah, I will do that. So I'm going to my Zoom chat. Let me stop sharing first, and yeah.
No questions? This is your chance. And if you don't have any questions and want to learn the basics of Python, there are several free resources out on the web that you can start to learn Python. And if you want step-by-step way of learning it, I dropped the link to 5-day challenge, which allows you to, I sent it that. So take a look at that link. You can get started with Python with easy 5 steps, like I said, 20 to 30 minutes a day. And Vlad has taught several of Opticent Academy students on how to start using Python. At that point, some try to go deeper. Some say, this is not my cup of tea. I don't want to learn it. That's either is fine. At least you get exposed and figure out, is it for you? Is it easy to learn? Because a lot of people get overwhelmed by saying, oh, this is programming. I can't learn this.
Well, the thing is that
Difficult.
it's not, don't think about this as programming, right?
Yeah.
It is a not, Excel, for example, is a point and click tool, but you have other tools where you have to write your instructions, right? So the high level data analytics tools that Python has, basically consider them as, your tools where you have to write instructions programmatically rather than click and point. And it's also better because in terms of reproducibility, because if you write something as a line of code, it persists until you need to use it next time. If you point and click, everything is lost because, the process is not really logged in any kind of code. So.
Yeah. Okay, Karen, can you include a link to your course? Yes, I did include a 5-day challenge, and then I will also include a link to the data science, digital data science program. That is a 10-week program. And if you sign up before January 15th, then you get a deep discount. After January 15th, it'll be regular price, but then you can wait for next session, which will be after 3 months, maybe 6 months. We haven't planned on that one yet. So 2 things that are happening. I would suggest if you haven't done anything yet in Python, start with 5-day challenge. That's only like $10, less than $10 actually, $9.90 something, 99. You can start to learn Python and see if this is for you. If you feel it's for you, then go for the bigger program. If it's not for you, hey, it's only $10. You learned something new, and you should be good to go from there, right? At least you
the challenge is worthwhile taking because it really breaks the ice. I mean, it shows you how doable everything is in Python if you are an analyst, but not necessarily with any programming expertise, right?
Yeah, here it is. I am going to drop the 5-day challenge again. 5-day challenge. Here it is. All right, any other questions? No?
Just standing by for questions, but
I am going to put this in the student resources on Optizent Academy so we can get this Kaggle link. And this is ad click data, ad click prediction data. All right, I have a question from Dave Khan. How do you pull out clicks or no-click data from the present Google Analytics 4 or other kind of advertising platform? So great question. Let me just, I was typing something here. So no-click versus click is going to come from your advertising platform. They should be able to give you. Now, Google does not give you that. I think the way you can look at it, and this is what I was talking within the during the session. So you know how many impressions happen of a particular ad. You know how many clicks happen on that ad, right? You can take that data, and which is available in Google Ads, which is available in Facebook Ads. They tell you how many times your ad was shown and how many clicks happen. You can use that level of data. Now, when you go to Google Analytics 4, you do not know the impression count at that point. All you know is which ads were clicked so that user landed on your site. So you have number of clicks happen. You can get the impression numbers from your advertisers, your publisher. You have number of clicks that are coming to your Google Analytics 4. It's available in BigQuery. You can't get it from Google Analytics 4 interface. So you have to integrate BigQuery. Now, if you want to know how to integrate BigQuery, I do have a video that I did a live session on this channel, which is Google Analytics 4 plus BigQuery. it shows you the type of data that's coming through. You can use that integration. I walk you through the steps of integrating that. I also have a complete course that'll walk you through these steps to prepare your data, to look at different elements within BigQuery if you're interested. But I would suggest to start with that free video that's there, and you should be all set. And then you can pull the data to do these kind of predictions. If you do run into any issues, feel free to reach out to me. Any other questions? All right, if you don't have any questions, I'm still gonna wait. We'll still be here. You can always come back and post a question, comment, and we will respond to those. Make sure to like the video if you like this session or other videos. And also make sure to subscribe to the channel. We will be doing more live sessions. I will be also bringing, Vlad will come here and talk about other elements, like what else can you do? Here we talked about ad clicks. Maybe we'll do another use case that you can take a look at. We've already done 2 other videos, so you might want to check those out on where to use Python or any, doesn't have to be Python, but using any data science elements to on your marketing data. So to check those videos out as well. Vlad, anything else you want to add?
Thanks, everyone. Just wanted to mention that we also have other, as Anil just mentioned, we have other use cases that also can be used to learn and practice predictive modeling, and that are also highly relevant to digital marketing. So a couple of them I wanted to mention is recommendation systems is one, and another one is text analytics, analyzing sentiment and analyzing also customer reviews and, let's say, things like customer complaints. So gives you 2 additional angles, of predictive modeling, 2 additional, basically broad methods in predictive modeling, such as recommender engines, right? Those systems are now really part of many online platforms, starting with Netflix and Amazon, and all the way to anyone who wants to use, who has enough data to build recommenders. Also, text analytics is something that is really interesting to learn, and it's extremely useful if you want to deal with, social media postings, materials from social media, and any type of user-generated content, which can be used to learn a lot of, text contains insights. There is no question about that, but how do you programmatically access these insights? So come and learn about text analytics, and you will know how to deal with, reviews and anything else that is free text.
Hey, that made me think. So since we're saying, hey, learn Python, can you do that on like a job site, sites like Indeed or somewhere, and then figure out how many companies are looking for Python or have job openings that are Python related or SQL or digital analytics related?
Yeah, Google actually has this as one of their pre-trained models.
Oh, really? Okay.
Google AI, they have Google Jobs or something like that, where you can actually provide your content and actually learn a predictive model regarding specifically job openings. But yeah, definitely you can do something like that. As long as you have data, you can learn all the patterns that are hidden in the data, right? Yeah. Which is what predictive modeling is.
Cool. All right, this was very useful. Every time I talk to you, I learn something new. So this was, and then my brain starts to work on like, okay, how can we use this for other scenarios? So this has been wonderful for me. I'm sure for the people listening as well. And feel free to leave a comment on this video even after we're done with the live stream. And I highly recommend that you check out this 5-day challenge that Vlad runs. It's on Optizent Academy there. So there is a link that I placed here. So in just 5 days, starting January 4th, I think, I don't remember the date right now, but starting January 4th or whenever it starts, within just 5 days, you will feel so much confident about using Python. All your
Yeah.
fears about whether it's, hey, it's too complicated or complex will be gone.
Yeah,
And then
and
if it is for you, then you can sign up for the bigger 10-week program. You will be ready for job after that. That's my looking at the curriculum, looking at the way it is, you will know a lot more than many people in the industry even know. So you're welcome, Karen. Karen says big thanks. I hope
welcome.
this was
Thank you for
cool
listening.
for everybody. So cool. All right, I'm going to give a few more seconds for any questions. If not, then we'll end the stream. And then we'll plan for the next one. I want to see another use case.
Yeah, absolutely.
Yeah. All right, seems like no questions. So I'm going to end it. Thank you, Vlad.
Yeah, thank you everyone for listening.
Thank you, everybody. Make sure to give this video a thumbs up and subscribe to the channel. We'll see you in the next live session. We have another one. This is one of my students from my previous classes. He is now running a data and or he is part of the data and analytics team over at a large B2B company, and he will talk about the challenges of marketing and lead gen, et cetera, in B2B space. So make sure to watch out for emails from me, and then I'll see you in the next session.